Melting of the great ice sheets of Antarctica and Greenland have together triggered a sea level rise of just over half an inch between 2003 and 2019, roughly one-third of the total global sea level rise during that time. This according to a new study published in the journal Science in the spring of 2020. Lead author APL-UW's Ben Smith and his colleagues paint a detailed picture of how the Earth's ice sheets have responded to climate change in the 21st century.
It's exciting because we now have a long period of time over which we have measurements that we can be very confident in.
Confidence based on measurements generated by the most advanced Earth-observing laser instrument ever flown by NASA.
Liftoff.
The Ice, Cloud, and Land Elevation Satellite, ICESat.
To explore the polar ice sheets of our constantly changing home planet.
ICESat-2 is particularly interesting for us because it's a repeat of a satellite that NASA launched in 2003 called ICESat-1. ICESat-2 and ICESat-1 make the same kind of measurements. They're both measuring the surface height of the Greenland and Antarctic ice sheets. And they're doing it in the same way with a laser. So they're bouncing laser pulses off the ice. So that means that we can get very comparable measurements between these satellites. And if we compare the measurements between one satellite and the other, we get really accurate measurements of how the ice sheet has changed over that period of time. To get comparisons between ICESat-1 and ICESat-2, we had to find the places where the tracks crossed. So we call those crossover points. And the good news is that there are a lot of them.
Ben Smith notes that if you watch a glacier or ice sheet for a month or a year, you're still not learning very much about it. But having a 16-year-long span covered by the satellites gives him confidence that the changes in the ice have to do with the long-term changes in the climate.
We took those measurement points where we could make a 16-year difference between the two satellites, and we converted those into rates of elevation change, and then we made a detailed map from those, filling in the gaps between the measurement points to make a smooth picture of how the ice changed. Warmer ocean waters are eroding the ice where it meets the ocean. There are ice shelves at the downstream end of those glaciers. The ice shelves are thinning, which lets more ice flow out into the ocean. In Greenland, we're seeing a lot of strong coastal thinning, and that is a combination of extra melt from warm summers and smaller snowfalls during the winter, and also due to glaciers that have sped up. That's a result of warmer ocean waters eroding the downstream ends of those glaciers.
The team estimates that since 2003, the ice sheets of Antarctica and Greenland have lost, respectively, 118 and 200 gigatons of landed ice per year, leading to the half-inch rise in global sea level.
We've got a very unambiguous set of measurements that are telling a story that is not completely unfamiliar to the scientific community, but it's important that it gets told in a very clear way. And I think that that's the contribution we're making here.